Alright guys, welcome back. This is Professor Hank, and in this video I'm going to talk to you about the C++ string class. Okay, so let's go ahead and dig into it. The C++ string class is an abstract data type that allows you to create variables of type string. Right, so this means that since it is an abstract data type, it's not built into C++ like say int or char. Okay, so if you want to use this thing, you have to do hashtag include string or pound include string. Okay, this is where the string class is defined, is in this library, and so you want to make sure that you always, if you're going to use this data type, you always want to make sure that you're doing your pound include string. Okay. Now we'll learn about how we can read strings in from the console, and you can do that. Read an entire line, whatever the user types, spaces and all, with the getLine function. So I'll show you how to do that. You compare strings with each other, or to each other, or against each other by using the relational operators, to see if a string comes before the other or if they're equal, for example. Show you different ways of defining string objects. So you can create a variable of type string like you can, or similar to how you create other variables like ints and doubles, right? But there's other ways that you can do it as well, because since a string is defined by a class and we can create an instance of that, we can create an object in memory of that class, it's more powerful, right? They're more intelligent, they have their own functions, and so we'll be able to use some of those functions to create strings in different ways. We can do concatenation, the addition operator, and the combined assignment operator plus equals is overloaded for the string data type, so we can use that to do concatenation. And then we'll run through briefly, maybe not all of these, but some of them, different member methods for interacting with strings. Okay, so let's go ahead and get started. I'll just write a program and we'll try to get through as much of this as we can, as quickly as we can. Alright, so I've got Visual Studio all ready to go, and you'll see here that I've done my hashtag include string, and this will give us access to the string data type, the string class, and then IOStream for CIN and COUT, and then using namespace std because I'm lazy. I know, you shouldn't do it, but I'm just trying to show you strings, so I don't care. Okay. So how can I create a variable of type string? Okay, well, just use the string data type and name your variable as you wish. Okay, so that's how we can do that. And you can initialize it to something, right? So you could do something like, hello. Okay, and then you can send it to cout. Okay, we'll go ahead and run that. Send it to cout, and you'll see the hello on the screen, fine. So there you go. All right, and then you can leave it uninitialized, and we could then maybe ask the user, right? Enter a string or something. Okay, so CNS, and that'll allow the user to store a string that has no spaces in it. So maybe Concord, for Concord, California, right? Hit enter, and then you can see the Concord on the screen, right? But the problem with that is, what happens if you do San space Francisco, right? All you see is the San. Where'd the Francisco go? It's because this operator right here, this stream extraction operator, it stops reading characters from the keyboard buffer as soon as it comes across white space. So it read the S, the A, the N, and then stuffed that into string variable S, but then just left Francisco in the keyboard buffer. So that Francisco never got stored. So if we want to get the entire thing, white space and all, then we use the getLine function, and we specify where the data stream's coming from. So CIN, right, this is coming from the console. And then for the second argument, you use the string variable where you want to send whatever they're typing. Okay, so in this case, now I can include as much white space as I want. So let's say San Luis Obispo, right? So I got two spaces in there, and now you can see I got the entire string. Okay, so you can do that, and you can also compare strings against each other by using your relational operators, right? So let's create a couple of different strings here, okay, and then we'll compare them. So enter string, cout, enter another string, okay, and then we'll get line cnt, and then we can use these operators. If s equals t, right? This is something you couldn't do with C strings. Now, if C++ had been invented for no other reason than to be able to make this data type string, it would have been worth it, because string processing is a pain, right? Especially, back in C, you got arrays of characters, and so doing this equality, you have to write a function to do it, or you'd have to go use the string_comp function from the string.h library and all that. Well, no, you don't have to do that. That's all built in. That functionality is built into the string class, right? So if s is equal to t, then we could say, hey, they are the same, right? Otherwise, else if s is less than t, we can say, s is less than t, right? The first string is less than the other one. Okay. Otherwise, we can say cout t is less than s, right? So you can build a decision structure based off of these relational operators, just like they were integers. These guys have been overloaded for working with string data types, right? So I'll go ahead and try this. Okay, so I'll say hello, that's my first string, and I'll say hello, that's the second string, and so that's going to say that they are the same because s equals t evaluates to true. And then I can also see if one comes before the other. So let's say car and then wash, right? And so string s comes before t, car comes before wash, because lexicographically car comes before, right? So the c is less than the w, therefore car is less than wash, okay? Okay, so another thing that I can do here is I can use this fill option, where we're going to take an integer as the first argument and a character that you want to fill the string with as the second argument, right? And so what that'll do is that'll create a string of 10 of these characters, okay? So you'll see that appear on the screen as well. So there's 10 pluses. Let's see, so I'll create another string up here, and we'll call this hello underscore world, okay? And so then for string s, what I can do is I can say, all right, well, let's go ahead and initialize it with t, but I only want part of the t string to make up my s string. So maybe I only want hello, and so I can say, all right, we'll start at that index, and then we'll go through, so that's 0, 1, 2, 3, 4. So we'll go through the fourth index, okay? And so then string s will be initialized with string t, but only these 4 characters right there. Okay, so let's try that. And so there's your hello, okay? Now we can use array notation. So for example, if I wanted to show you the second character in that s string, I could use an index here. I can use a subscript here, and that'll access that second character within the string. There it is, right there, the L, which is the second one, right after the E. Just like an array, just like any other array. All right. So next up, let's talk about concatenation. So concatenation just means joining together, right? It's appending. That's another term for it. So I could have string s, and I'll initialize that with hot, right? And then I'll create another variable, and I'll initialize that with space dog, right? So if I were to print those out one after the other, on the screen, we're going to see the hot space dog because I printed two variables, right? But what if I wanted to create yet another variable that was a combination of the two, right? Combine them together. Okay, so what I've done is I've created a brand new string called hot space dog, or that contains hot space dog, and I've assigned it to u, right? And so now I can print out that u, and you're going to see the hot dog, my new string, which was a concatenation of the two. Another thing you can do is you could just modify the original s, right, by doing something like this. You could say plus equals t, right? And so when you do that, that's going to take whatever's in t, right, these four characters, and then it's going to tack it on to whatever's in s, right? So s is going to become hot dog. Okay, so there's the hot dog, which is a result of C out S, right? So that's an example of concatenation. And remember what plus equals means. It's the same thing as saying S equals S plus T, right? So plus equals is just a shorter way of doing that, right? So what I want to do next is I want to go through some member functions. And, maybe we won't go through all of them, but we'll just give you a feel for how these things work, or what some of your options are. Okay, and so since they're member functions, they belong to the string variable. They're like variables that have functions built inside of them because it's an abstract data type. It's defined using a class, and there's functions and data that are wrapped up together. So, for example, I could ask the string, how big are you? Okay, and so this will count how many characters there are in the string, and we'll put it inside of the length variable. Okay, so gonna see that. Oops. What am I missing here? Oh, I forgot my semicolon. Sorry about that. So we'll go ahead and run it. So our size for S, it's actually 7. I misspoke, right? Because we have the S equals S plus T here. So hot space dog is 7 characters. So let me delete that. Made 2 quick mistakes there. So there you go. There's the 3 characters that we were expecting, right? 3, the size of S is 3. All right. So the length member function does the same thing, right? So 2 names for the same functionality, right? So you could go with either, whichever one you prefer. I mean, there's really no practical difference. Another thing you can do is you can do that appending, that concatenation, by using the append method, right? So if I wanted to append space dog to the end of string S, well then s dot append will do it, and then I can show you how S has been updated. So hot dog, right? You can do that. You can also specify individual characters. So for example, you could say that we're going to have 4 characters of Z, okay, and that will add Z onto the hot, okay, so there's your hot Z. All right, so we can also append, similar to what we did before, we can say, well, let's go ahead and take some characters from T and let's add them on to the end of S, right? But let's start from the second position, right? So, we're going to have, this would be the first position, this would be the second position, so you can imagine index 0, index 1, and actually I got my arguments backwards here, sorry, 2, 1. Okay, so that will take, let's fix that. So that will take all of the characters starting from element 1 here to the end and throw that on to the end of S. So you're going to see that here in a second. All right, so there's the hot dog. No space because I said, hey, append from that second position, skipping over the space. All right, so instead of using that array notation, so instead of this, right, s of 0, say, right, we can do something like this. S dot at. Okay, so that might look familiar to some of you guys, for some of you Java people. So there's an at method that is included for this class. So we see the H because we said, hey, give me the character that's at the 0th position for string S. And so that's at the 0th position, that's index 0. Now let me show you this assign method, which is useful. And there's different versions of this too. I won't go through all of them, but similar to how we were using integer and strings as arguments, there's similar versions of it as well. So let's say that you can do this with strings or with character arrays. So let's say you had a character array name, okay, and you had it initialized to say Hank. So what you can do is you can say, s dot assign name, okay, and so what that'll do is that'll copy that character array, that C string, into S, okay. It's kind of like doing something like this, okay. It's just a wordier way of doing it, I guess you could say. Okay, so then when we print out the S, you can see there's my name. Okay, the back method is going to give you the last character of the string. Okay, and so you can see s.back is T, because remember I just got rid of the s dot append, so we see the T, so we're back to the hot, and so back will give you the very last character. Okay, so the next thing I want to show you is the C underscore stra method. So it looks something like this. So what this does is returns a pointer to a C string, representation of the string that is being stored inside of S, right? So if you need a pointer to a C string, say you're going to pass it to an fstream object's open method, well then you can do this. You could also pass it to, say, the string function or any of the C string handling functions. Okay, so that just gives you a pointer, right? So we could do something like this: char star p equals that, right? Anywhere you need a pointer to the C string that's a representation of hot here, or the C string hot, because that's what this is going to return, is a pointer to a C string. You could assign it to a pointer variable, you could pass it to a function. Maybe you got the string function, you want to pass it to that, okay, fine. And so if you need a pointer to a C string, or if you need a C string version of whatever the string variable was holding, then C underscore string is your guy. Okay, and next up I'm going to show you the clear method, and that'll allow you to delete the string that's being stored in the string variable. So we can use cout_s, right, and then do s.clear, right, and then from there we could say something like, well, if s.size is greater than 0, cout s. Okay, well, guess what? It's not going to be greater than 0 because I cleared it. So we're only going to see the hot the one time, right? Else, maybe we'll even say cout s is empty, right? Because the size is now 0 because we deleted all the characters that made up the string that was being stored inside the s variable. Okay, so that's what clear does. Right? We've got a compare method, which basically works in a similar way to how strcomp works, right? strcmp. So let me show you that really quick. So s.compare with string t, okay, and this returns an integer, int I'll say x, okay, and depending on if one character or one string comes before the other lexicographically. Okay, so I'll show you what I mean here. Right, so you see that 1 is displayed. So that's saying that the second argument, in other words, the second string, this T right here, that comes before the S does. Okay, now if I did it the other way around, right, if I compared T with S, that should be a negative 1. Because this is how the strcmp works, right? So that's saying that the T comes before the S. And then, of course, if they were the same, for example, if I compared the string versus itself, well, that's going to return 0, because that means that they're the same. So compare works like that strcmp function that's defined in the C-string library. Let's see here. Is there anything else I want to show you? Yeah, a couple more things here. The front method is the opposite of the back method, right? So what does that do? Well, you can imagine that's going to return the very first character in the string. So we'll see H there. There it is. Let's see. I already showed you size. You can swap the contents of 2 strings by using the swap method. So what that'll do is that will make S and T exchange, right? So CLS T. Okay, and let's go ahead and run it. So you're going to see the S and the T, it's going to be backwards, right? Dog and then hot, because swap took what was in T, put it in S, and then put what was in S and put it in dog, right? So you can see that space dog and then the hot, right? So that can be convenient. And then let me show you one more here. I'll go ahead and, well, maybe a couple more. I'll show you erase also. Okay, so if you wanted to delete just certain characters within your string, then you could say s.erase, and from there you could say, I want to erase, I don't know, maybe 1 character starting at position 1, right? So we're going to get rid of the O, okay? So I mean, there's all kinds of these little methods here that can make processing your strings, you know, way easier, right? So the O's gone. You know, you don't have to write these functions on your own. They're built into the string class and therefore the string objects. And so then, you know, whatever you need to do with your string, you know, you just find a method that does what you want it to do. Okay. Let's see here. So let me show you find really quick. So s.find, okay, and the way this works is you can say, all right, I want to know where a particular character or string starts. Okay, so you could do something like, you know, I want to know where the O starts. Okay, and that's the first argument. And the second argument is, you know, start the search from some place within the string, right? So if I want to start the search from the very beginning, then I could use O here, right? Because that matches up or corresponds to subscript 0. Okay, and so then I'll just see out what it returns, and if it finds a match, then it'll go ahead and return the index of where it found it. So it found the O at index 1 because O is in the second position within the string. Okay, now you can also do that with substrings. Works the same way. You know, you would just put your string as an argument instead. Okay, let's see here. We can insert into the middle of strings. So you've got the insert method. Okay, and we can say here, starting at the second position, I want you to insert string T. Okay, and So what will happen is it'll take this string here, dog, and then it'll insert it in the middle there, okay? So let's see what that looks like. And there's different versions of insert as well. Right, so you can see that the space dog got inserted at the second position, right? So there's all kinds of these methods that you can use to make living or working with strings much, much easier, okay? So you can get a substring by using a string, or the substring function, right? So let's say that I had San Luis Obispo, okay, and I wanted to just get the Lewis out of there. So what I could do is I could say s dot substra, okay, and what I can do is I can say, okay, well, here's how many characters I want to extract and from where. So this would be 0, 1, 2, 3, 4. So from index 4, let's grab 1, 2, 3, 4. Let's grab 4 strings, okay, or 4 characters, sorry. And then we'll just send that straight to CL. We'll see if I did my math right here. Maybe, maybe not. You know, doing this live, all in one take. So yeah, there you go. So Lewis, right? So we were able to extract the substring. Now, just sending it to cout, not too exciting, but you know, you could assign it to a variable, right? And then use that variable for further processing, right? There's nothing saying that you can't do that. Okay, so you can use these methods in all kinds of interesting ways, and I think that will be the last thing that I show you. Okay, so what did we go over in this video? You know, I just kind of expanded on maybe what your knowledge was of the string data type, right? So pound includes string, okay? Now, some of you out there are going, I don't have to pound include string, I pound include IO string, that works. Yes, but you can't depend on that, right? That's a quirk in the standard template library, which they could change at any time. If you're going to use something that's not built into the language, make sure that you pound include or hashtag include whatever header file that it belongs to, right? So, you know, pound include string, and then I showed you different ways of reading in strings, using cin, using getLine, showed you how to compare strings against each other using relational operators, showed you how to do concatenation using arithmetic operators, you know, showed you how to initialize strings, how to set up string variables in different ways, which you might not have known. Something a little bit more interesting than just s equals string s equals hello. And then finally we went through a bunch of different methods. There's more than that too. You know, if you want to learn all there is to know about that or get more exposure or read up more on it, then you know, you can go visit c++.com or c++reference.com and see a complete list. But hopefully that gives you a feel for what the string data type, that string class, that string object is capable of. Okay. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up, and if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.